An alkene can react with a water molecule in a reaction called hydration. This reaction is catalyzed by an acid. Remember catalysts, we write the formula for them underneath the reaction arrow. The catalyst that we use for this reaction is sulfuric acid, H2SO4. The products of this reaction are similar to the hydrohalogenation reaction, the hydration reaction, and the halogenation reaction. Our carbon-carbon double bond will be converted to a carbon-carbon single bond. All of the things that were originally attached to the carbon atoms are going to continue to stay attached to the carbon atoms, and we'll be forming two new bonds to the carbons of the alkene. The new bonds that we're forming are a bond to a hydrogen and a bond to an OH. We sometimes call that an OH group. It is easier to visualize where these come from if we think about the water molecule in terms of its actual molecular structure, HOH. So when we see it as HOH, we can see that the molecule of water is being divided at this point right here. And the hydrogen is going into one of the carbon atoms and the OH is going onto the other. And one last thing before we look at some more examples, there are several different ways that the H2SO4 catalyst is written in this reaction. Sometimes it's just written as H+. That's an abbreviation for H2SO4. Sometimes it is written as H3O+. That's also an abbreviation for H2SO4. Let's look at a couple of examples of this reaction. Let's do, for our first example, let's do this alkene right here. And to give you just some variety in the notation, I'm going to put the H2O on top of the arrow. That's something that we've seen before, and I'll use H+ as the catalyst, as shorthand there. So for this reaction, we have, we call this an asymmetrical alkene. It's an alkene that is different on the right-hand side from the left-hand side. Let's just begin by drawing all of the alkene molecule, but converting that carbon-carbon double bond to a single bond. We're keeping everything that's attached to the carbon atoms, we're keeping them in place. And let's make some room for our new bonds. One of those is going to be a bond to a hydrogen, and the other is going to be a bond to an OH. Where should we put the hydrogen and the OH? Should the hydrogen go on the left and the OH on the right, or should it be the other way around? OH on the left and hydrogen on the right. If you watched the last video, you are already familiar with Markovnikov's rule. If you're not familiar with Markovnikov's rule, maybe back up and watch that video again. Markovnikov's rule says that the hydrogen atom will go onto the carbon that has the most bonds to carbon, or to hydrogen. This carbon atom has 2 bonds to carbon atoms, or hydrogen atoms. This carbon atom has 1 bond to a hydrogen. And remember, we don't count these guys over here. We're just looking at the hydrogen atoms that are directly bonded to the carbon atoms of the alkene. The carbon atom on the left has the most bonds to hydrogen, and that means that it's going to get the hydrogen of the H2O, and the other carbon will get the OH. Let's look at one more example using line notation. We'll go with this, and this time we'll say H2O, H3O+. You know, sometimes it's possible for somebody to just write H3O+. Like that's sort of adding H2O plus H+, mixing it all together. So I'm just going to leave that there just in case you might encounter that. So for our product, we're going to redraw the molecule, getting rid of that double bond, and we're going to give ourselves space for the new bonds that are being formed. One of these is going to get a hydrogen and the other will get the OH, or maybe it will be the other way around. We need to use Markovnikov's rule to help us figure out where the hydrogen will go. Looking at this first carbon of the alkene, this carbon has 1, 2, 3, 4 bonds, which means it does not have any hydrogens. This carbon atom has 1, 2, 3 bonds, which means it does have a bond to hydrogen. So our new hydrogen will go onto that same carbon, and our OH will go onto the other. And then remember, just like we saw in the last video, we can't leave our drawing like this. In line notation, we're not allowed to show carbon-hydrogen bonds or hydrogen atoms that are attached to carbons. We have to erase this because it's not allowed in line notation.